This morning we're in a very nice late model JK with an LT1 10-speed. Let me qualify that. This might be an L86. I can't tell the difference. I think this is one of our new L86s with the LT1 intake. And in my opinion, they run identical. Some guys say there's a difference, but I don't notice it. But the point is this really is the pinnacle of engine change technology today. And I was just thinking to myself, where we came from. I was born in the 60s and grew up in the 70s. I got my driver's license in the late 70s, which is pretty much the bottom of engine performance in the American automotive world. I remember in those days 200 horsepower with a smog motor, a small block Chevy, even 350 cubic inch engines were putting out under 200 horsepower, and they were burdened with smog, and these engines really weren't designed for emissions to begin with. They were leftovers from the 1950s. I was just driving a LT 5.3, which is about 326 cubic inches, about the same as the old 327 engine, if you remember those. I really like the 327 engine. It was a combination between the 283 and the 350, which gave you the best of both worlds. It had decent torque, but it also revved pretty good. As a side note, we have an original 69 Z28 in the shop. I have 3 or 4 69 Z28s, and this is a 69 that has the DZ engine. The DZ engine had the large journal crank of the 350 with the stroke of a 283. So that means it's a custom crankshaft that GM built specifically for the 69 Z28. And remember, in the late 60s, GM was cleaning up on the Trans Am circuit, not just because of engine performance, but because of braking technology and other things. Prior to the DZ engine, there was the MO engine, which is the 67 and 8 engine, and they did run a 283 journal crank. And they did really well, but obviously the 69 engine with a beefed up crank was better. And that's kind of an illustration of the evolution of engine performance. Because in the late 1970s and early 1980s, we didn't have a whole lot to work with. We had these engines that were designed in the 1950s that were burdened with emissions devices. Really, it was the late 50s through the mid to late 1960s that was the heyday of the muscle car. And what that means is the manufacturers could do whatever they want. They could raise the compression. We had high octane fuel. We had better oils because of World War II. So we could take these engines that were designed way back in the 50s and apply hot rod technology to it. Now, we weren't applying high technology to it, which a lot of the Europeans and Asians were doing. They were adding multiple valves, like 4 valves. They were adding multiple camshafts. You look at a 4-valve V12 from the 1960s or even 70s from the Italians, they were way ahead of what we were doing, but they were also really small engines, just a few liters. So what did we do? Well, we ripped the heads off and we put on better heads. We raised the compression. Obviously, we put the big camshafts in, and we had the rumpity-rump engines. And while these engines were fast, they really weren't that efficient, and they did put a lot of emissions out. I have a 1970 LS6 Chevelle, an original LS6 Chevelle. And I used to call it the earthquake because it just idled so rough. It was so loud. It had 410 gears in it. It was miserable on the highway. But if you put slicks on it, you could get into the 12s, maybe the 11s. And in a big heavy car like that, back in the day, that was really good. Today, electric cars can do that, as well as a host of other modern muscle cars. But you got to remember what we were working with. We were working with primitive chassis. And by all rights, while the muscle car era was awesome, there was a lot of cleaning up that needed to be done. I had a 66 375 horse Chevelle, and it was really fast. It would accelerate hard, but it sure wouldn't brake that well. It had a single master 4-drum setup on the brake. So imagine a vehicle with nearly 400 horsepower and a single brake system with all drums that would fade, especially if you went through water. And as far as the emergency brake goes, back then it was more of a suggestion than an actual brake. So safety was definitely a concern. I had a lot of Chryslers. As you guys know, I had Hemis. One of my favorite cars was the 70 Challenger 340 TA or Trans Am, similar to the AAR Cuda. A lot of you guys didn't even know what it was until recently. Chrysler reintroduced it, but it was a 340 6-pack made for Trans Am. They made a few thousand of them, I think about 2,000, and how the 340 got into the street, I'm not sure, because Chrysler de-stroked or de-bored them to get them down to like 305 or 30 something, because the Trans Am back then was limited to 5 liters. But it was an awesome car. It was very quick. A lot of guys called the 340 6-pack the giant killer because it would run with the big blocks. It had special heads, special cast headers, and it had a tri-power on it that had a lot of CFM. And while that car could accelerate hard in a straight line, it was horrible around turns. It had a great ride, but forget about going around a turn hard in that car. The early Chryslers had the torsion bar suspension up front, and it wasn't ideal. So again, the chassis, the brake systems, suspension just weren't up to the horsepower of those cars. If we look at emissions, in the 1950s, the horsepower boom started. We had the technology from World War II. We had better gas, we had better oil, we had better metallurgy, and we had better means of production. Because remember, in the 20s and 30s, the V8s, the straight 8s, the V12s, even V16s, they were exclusive luxury car engines. In the 1950s, Ford, Chevy, and Chrysler all released modern, or at least for that time, modern V8s. Ford had their Y block, GM introduced the small block, Chrysler had a variety of V8s, including a Hemi. There's still a debate what was the first engine that had 1 horsepower per cubic inch. Some say it was the 283 Corvette. Some say it was the Chrysler 300. But in any event, the horsepower just rose and rose and rose from the late 50s right up through the 60s. And for good reason, insurance companies started to get nervous. The manufacturers played games in the late 60s and early 70s with horsepower. They would derate the engines for insurance purposes because the insurance companies are really coming down hard on the muscle cars. When it comes to emissions, California really cracked down. I lived in California and I did see the smog. So in the Ronald Reagan era, when he was governor, he started the Air Resource Board. And for the most part, in the late 1960s, he did some sensible things to clean up emissions. Getting rid of the road draft tube and putting in a positive crankcase ventilation system was huge. That cleaned up a lot of the emissions that this country was seeing, because then combustion byproducts weren't just blown into the atmosphere, they were sucked back in and reburned. But by the early 1970s, things started to get crazy. They came out with the exhaust gas recirculation system to reduce NOx. Because in the late 1960s, they kept leaning the motors out to reduce the hydrocarbons and COs, which are basically fuel or gas, but they still saw that haze. And what they didn't realize was, by leaning these engines out, they were increasing the combustion chamber temperature. And when they got past about 2,500 degrees, nitrogen and oxygen would melt together and create NOx. NOx is a whole subject not by itself, but just know that one of the NOx's, X does stand for any number of oxygen atoms melted to a nitrogen atom, was photochemical smog, and that's what we were seeing. So as they leaned these engines out, we were seeing more and more smog, which is a combination of smoke and fog. So they learned about NOx and COs and all this stuff, and the EGR valve came out in the early 1970s, and like every other technology, there's several different ways tried. Chrysler had their fixed orifice EGR system. Most everybody else used a positive or negative vacuum diaphragm that would open a valve. And they had solenoids control them. By the 1990s, the EGR valves were still popular, and they mostly went electronic and digital with feedback sensors and exhaust gas temperature sensors. Toyota was big in that in California, and that didn't turn out too well for them. The air systems were really complex, especially the pump air systems. Secondary air systems put oxygen into the exhaust to complete the combustion cycle, because especially with the high performance engines, you're putting hydrocarbons, which is raw gas, CO, which is partially burned gas, and you have heat in the exhaust. What are you missing for combustion? The fire triangle. You need heat, you need fuel, and you need air or oxygen. So by putting oxygen into the exhaust, we can complete combustion and lower the emissions output of the vehicle. Well, the air systems got really crazy. They had to have check valves to protect the system. They had to have diverter valves to prevent backfiring. Some guys call them anti-backfire valves. And I have a California 1967 Corvette Tri-Power Coupe, 435 horse. It's a beautiful car, but it's got the smog trees and the smog pump and all that stuff they tacked onto it. And again, this is an add-on. This is an engine that was designed without emissions, where emissions were added to it. Did those systems work? Yes, they kind of did. They weren't as reliable as today. To give you an example, today you're not seeing a whole lot of EGR valves on the modern GM V8 engines. Yes, we did see them in the small block Chevy and the V6s and even some of the early LSs, but by the time the Gen 4 came around, GM was handling NOx emissions through other ways, mainly through variable valve timing. Because with variable valve timing, you can control the combustion chamber temperature. And by lowering that temperature, you could reduce the NOx emissions. Now today with the LTs, CVVT is one step better. You're not seeing EGR valves on these engines. You're not seeing secondary air systems on these vehicles. Of course, you are seeing PCV and evap systems on these vehicles because there's nothing you can do about vapor emissions. It's there. You put your gas in your car and it has to be stored. And as far as the PCV goes, that's positive crankcase ventilation, there is no downside to it, and it restricts blow-by going into the atmosphere. So realistically, the modern emission systems are not affecting performance, as proven by these modern engines. This LT1/LAD6 I'm driving is putting out what I would consider near 500 horsepower, and that's something you have to understand. The LT, while the LT1's rated at 460 horsepower, it'll take a 480 horse LS3. It'll take a 475 horse Hemi, because we are putting out tremendous torque right off idle. 2,000 RPM, it's 300 and something foot-pounds of torque, as I remember, where these other engines are having to rev up to 3, 4, 5,000 RPM to get maximum torque. So we're getting torque across the whole RPM band. So I'm getting too much into history, and maybe I'll go into that further, and I've also done it in the past. But really what you guys are concerned about is your Jeep. How can I get more engine performance? And every week I get the guy calling me up, hey, I want to put a small block Chevy with a carburetor in my Jeep. Can you sell me a harness? Hey, have you heard about this hydrogen generator? I bought it from a guy in a parking lot. And just all these different ways of getting performance out of a JK. When the JK came out in 2007, it was woefully apparent that it needed more horsepower, especially for modified vehicles. And the 3.8, and I think the 3.8 gets a little maligned. It was really an older generation engine, overhead valve engine, that especially with the automatic transmission was burdened in a large, heavy vehicle with poor aerodynamics. And then that 4-speed transmission just killed it. If you put an 8-speed behind the 3.8, it would have been a whole different situation. Now, it still wouldn't have been ideal. In fact, the 3.6 engine with a 5-speed was massively better than the 3.8. But you're still hauling around a brick with a small displacement engine, even though it had pretty decent horsepower. So here's my thought on the chain of engine performance mods up the ladder, with the LT1 10-speed being at the top of the ladder. And guys, you have to go drive one of these things. Once you've driven an LT1 10-speed, you can go drive everything else, and I think you'll agree with me that nothing else compares. And when I say LT1 10-speed, it could be an LAD6 10-speed. It could even be the 5.3 LT. They're awesome. I just drove one of those to Utah. Got great gas mileage, had good power. The drivability, the torque, just everything about these engines is a step above. So the first thing guys would do is they'd put cold air intakes on. They would put throttle body spacers on. And remember, anytime you mod something, and yeah, you have certain access to the tune so that you can tweak things. Chrysler does run speed density, so there is no MAF sensor. That makes it a little bit easier to tune. But at the end of the day, you still got a 3.8 engine with relatively low compression, burdened by a high friction, high temperature, 4-speed transmission. You guys that had the 6 speeds, you're lucky. You had better performance. But if you're going to free up the intake, you probably should free up the exhaust. So exhaust systems came out, and they became really popular. And I saw guys spending thousands of dollars in stainless steel exhaust systems. And really, you're just putting lipstick on a pig. You got 42-inch tires on your Jeep. You got light bars hanging off everywhere. Yeah, you're going to pick up a little bit of horsepower. But when you go from 200 horsepower to 215 or 220 horsepower, even 230 horsepower, you're not lighting the world on fire, and you're still not cruising at 80, 90 miles an hour up the grades in comfort. So then came the Superchargers, and the Superchargers made a lot of sense because they were relatively easy to install. They were a heck of a lot less money than a V8 conversion, but they also came with their own set of problems. One, these engines weren't designed for superchargers, so the longevity of the engine, and especially the transmission with the automatics, was reduced. Being speed density, having torque management-based transmissions, meant that when you put a supercharger on, these engines were designed for a 1-bar operating system, and now we're bringing them up to a 2-bar operating system, but we're trying to trick it and fool it. So the transmissions did funny things. They were burning out. I know AEV pulled some of their superchargers. I used to know Wes over at Manguson, and I work with Edelbrock, and you guys know the rips and all that. And yeah, I mean, if a supercharger is installed properly and used for an intended purpose, then it is a good option. And what is that? It's low cost. It does add significant power. It's not like just putting a throttle body spacer in. And with reason, you might get some longevity out of it, although there probably is going to be some maintenance involved. The lifespan of the engine is going to be reduced, and the resale value of the engine is going to be reduced. And I'm saying that because these V6 JK engines now are like gold. The Penstars, I mean, I'm seeing them go for $4,000 or $5,000. We used to practically give those engines away. In any event, the Superchargers, whether you went centrifugal or a root style blower, I'm a root style blower guy, they did add power, but there were all the downsides. The drivability, the longevity, etc. It wasn't a V8, but it was a step to a V8. But if you're the guy that was going to own your Jeep for a year and then sell it, you can put the supercharger on, enjoy it, take it off, sell your Jeep. If you're looking for a long-term solution, I don't think the supercharger is it. Superchargers technically do include turbocharger, and I drove a Pentastar twin turbocharged Jeep, and I gotta say, that thing had a lot of power. Was it a V8? No. Did it sound like a V8? No. Was it fast? Yes. I would say that thing was pushing close to 375, maybe 400 horsepower. The drivability wasn't too bad, but it wasn't near an LT1. It wasn't near an LS. It didn't have the linear throttle response. It didn't have the bottom end torque. It had lag, etc. With turbochargers, you're dealing with heat issues, especially like with water crossings and stuff. You could get water-cooled turbochargers, oil-cooled turbochargers, the after-run systems to keep the turbochargers from cooking themselves. The bottom line is they had their ups and they had their downs. So what comes next is kind of what's important. Motek's mission philosophy from day one was to stay all GM. I've always been a GM guy. I've owned Chryslers, I've owned Fords, I've had Shelbys, I own Hemis, but bang for your buck, you can't beat the GM powertrains. They always crank them out in more quantity at a lower cost. So in 2008, when I put an Alice into a JK, it was really my retirement. I had sold my automotive buildings, I was winding down, I had been a high-level emissions inspector and a shop operator for many, many years, and I didn't go into the JK market. The JK market came to me. And in the early days, the LS to JK conversion was a little bit tough because the way I interface things wasn't really meant for mass production. It wasn't meant for plug and play. It was just meant to work for me and maybe a few of my customers, because at that time I owned a lot of shops and we had a lot of customers with Jeeps that wanted this. We also had some customers with Hemis, and remember in 2008 the Hemi was just hitting the scene. Okay, the Hemi was a massive, massive improvement over the 3.8. Now, if you compare that old non-VVT 5-speed Hemi to a modern 8-speed VVT Hemi, the newer engine obviously has a lot of advantages and transmission. So the LS with the 6-speed was a perfect match for the JK. I don't think anybody in the industry will deny that. And I can name some of the biggest guys I've dealt with, even some working for Jeep, that agreed with me. The problem was either they had alliances with Mopar or the integration was too difficult. Over the next decade, Motek did slowly step up and improve the technology. We went from an analog digital integration to a CAN-based integration in about 2016. This greatly simplified the installation and improved the functionality. But we always had to stay committed to our mission goal of staying all GM. And there's a lot of reasons for that. Having GM harnesses. In fact, we're actually replacing harnesses from other companies that are just falling apart. They use Chinese connectors. The wires use plastic that just melts or gets soft inside the harness. So by going with a GM harness, you have your power distribution, your ground distribution, your failure mode. And I know a lot of you guys are tired of hearing this, but every day I see the advantages of these factory harnesses. We're using factory GM modules, that's ECMs and TCMs, operating systems, calibrations, and this is huge, guys. That means in most areas you can legally register your JK. Now, if you're a 49 state guy, or I'm going to call it 48 state now because I've been working with the Colorado guys for years, and they told me they're requiring an executive order. In the last couple Jeeps we did in Denver did use our executive order to pass and get registration. So if you're a 49 state guy, you got a pure powertrain, you got a GM engine, a GM transmission, GM wiring, because on our executive order, the wiring harness is part of the engine powertrain, as much as the modules are. So you got the GM modules, you got the GM calibrations and all that stuff. In fact, we have to submit CVNs or calibration verification numbers to California to get the vehicles passed, and they're stored in the database in Sacramento. A big problem with the earlier builds was guys were just turning off monitors and codes, and with a lot of the Hemi guys, all the monitors were turned off, and the early analyzers would only look at monitors that were set to support it. So you can see the problem. I actually met in 2015 with some politicians up in Carson City where this whole thing came down with the CVNs. Was the integration harder? Yeah, it was. Definitely harder than a Hemi or a hybrid, and we'll talk about that in a second. But for me, the benefits are just massive. I'm driving this LT1 L86 right now, and it's awesome. And we have a executive order in the works for these engines, so you can stay legal in most areas. And you can also sell your Jeep, because remember, if you tamper with your vehicle and you sell it to a guy and he takes it to California, Colorado, they could come back on you, and I've actually seen that happen. Being able to service and diagnose these vehicles with all factory parts is important. So a lot of times a shop will get one of our vehicles and they got one of your LS conversions in and it's got a coil code. I say, well, just go to Mitchell All Data and run it exactly the same way you would on the OE vehicle. The wire colors, the trouble charts, even run the factory GM power distribution connector. That's for all the fuses. So not only is the ground, but the power distribution circuits are all factory, and you can run them just like you would an OE vehicle using a GM manual. So by Motek staying pure to this philosophy is not only a benefit for servicing and emissions and drivability and updates, but it means we can pretty much run anything GM comes out with. GM comes out with an LS L94, we can support it. They come out with the Gen 5 motors, we can support it. They come out with an LT1, we can support it. The vehicle I'm in right now has a 2021 transmission, which originally came with a T93 transmission controller. Those aren't supported. GM has them locked down. But because we can run factory controllers and all we're using is our CAN module as an interface, it means that we can run it exactly the way GM intended it. And that's going to bring us into the hybrid. The hybrid has a lot of advantages and it has some disadvantages. The advantage is by taking a GM engine and modifying it to operate within a Chrysler operating system means that you won't have to work as hard to integrate a pure GM powertrain. Now with the CAN module, that's got easier and easier. But modifying an engine, modifying the firing order and the camshafts and trigger wheels and all that, and then building adapters to mate transmissions to engines, along with the emissions compliance, it really is a workaround way of getting a GM engine into a Jeep. And it works quite well. Recently we've taken a few of those hybrids and we've converted them to the Motek setup because they had 5-speed transmissions or things weren't working, and we put our setup in it, and in every case the customer commented how much better they felt the drivability was, especially going to an LT. The engine I'm in right now has 11.5-to-1 compression, and the way they're able to do that is through technology. Not only the direct injection, but the cylinder pressure control. We have a dual stage oil pump. We have low friction, pretty much everything. Even the alternators on these are low friction. I'm just a pure GM guy, and I have not seen the level of performance, economy, and drivability that these pure GM powertrains have in any other conversion, whether it's a hybrid or a Hemi. The 10-speed transmission has no match, in my opinion. The LT1 running the way it should, or even a 5.3, is phenomenal. It has a high value because the economy, the drivability, and the performance. The obvious choice for a JK is a Hemi. It's Mopar, and the Hemi's going to integrate the easiest, and it's the most popular conversion out there. Now don't just think bolting a Hemi in is going to be real easy. It's not hard, but you still do have to change the operating system with patches and hacks, and I mean, it's almost at an OE level now. Some of these companies have access to Chrysler, and they're integrating the Hemi better than ever before. The Hemi is a larger and heavier engine. It is cast iron. In my opinion, the transmission choices, even now with the 8-speed, are not up to the LT standard. They're lower compression. They're a toss back to an earlier era. The Hemi and the LS really are the last generation of engine. And when I talk about the Hemi, I think you can apply the same thing to the LS. The 6-speed is an older generation of transmission. It's a great transmission, just like the 6.4 Hemi is a great engine, but they are older technology. When you look at the specs of an LT, you look at the high compression, you look at the direct injection, high pressure fuel system, the 10-speed adaptive transmissions, they've just taken a step up. So that's not to take away from the viability of the LS and the Hemi. It's just, in my opinion, these things are a step better. So that's kind of my take on the Power Adder. Everybody has their own opinion about things. If you ever get a chance to drive one of these 10-speed LTs, do it. And we've got these LTs all over the country now. I've got them in other countries. We've got hundreds of them, maybe 1,000, I don't know. And if you can't find somebody with an LT 10-speed, just go rent or test drive a 10-speed Suburban or Yukon or Denali. And I think you'll have to agree that this powertrain really is top of the pile in the JK conversion world. We are going to take this late model LT 10-speed on the trail. We'll see you soon.